Okay, welcome to the Physionic Journal Club. If you are live or not live, I am going to be dissecting or going through kind of the initial thoughts on a particular paper called Resistance Training Volume Enhances Muscle Hypertrophy, but not strength in trained men. So the purpose of this particular paper, and this is actually done by Harris, James Krieger, Jozo Grigish. I don't even know if that's how you pronounce his name, but several people that are pretty popular in the exercise science field, especially around muscle hypertrophy. So what I'd like to do is go through kind of an initial take. I already went through the paper, but I'm going to field, if you are watching this live and you'd like to put in your 2 cents, I've got the paper linked. And if you're listening to this or watching this after the fact, then I've got the paper linked for you as well. So you can go through it because it's open source, open access. So what are they trying to do? Well, the title tells you kind of the conclusion that they think that they reached, but we're going to go through and figure out if that truly is the case. So what they're actually trying to do is figure out how much volume you need to be using in your training protocol to attain kind of, I don't want to say the word optimal, but the appropriate or high levels of muscle hypertrophy or muscle growth, as well as what volume does to muscle strength. So both of those are going to be addressed in this particular paper. So how did they go about it? Well, they had only male participants. For one, the participants were 18 to 35 years of age. They were natural lifters based off of a questionnaire, which of course, I mean, at any point a person could lie. But considering they have an N or a sample size, the number of participants involved were 45, which is a pretty large N, and they only needed, I think, 36, something like that, to conduct the study. They were well over. So assuming that a few people lied, it's not going to make a huge difference. It'll probably wash out with the overall sample, with the overall number of participants that they had. Now, these participants had to have been training 3 times a week, and they also had to have been training for a year. So these are, I guess you could consider them like barely beginning intermediate lifters. So kind of beginner to that intermediate level, but they do have some resistance training experience. Now, the individuals were stratified into 3 different groups. So you have the first group, which did 1 set per exercise, and that's important to note that it's not 1 set total, it's 1 set per exercise. And then they had another group that did 3 sets per exercise, and then they had another one that did 5 sets per exercise. So, and then they increased the volume slightly for those individuals that did lower body, because there's some evidence that lower body training, meaning your legs, need a little bit more volume than your upper body. So they increased the number of exercises that they did for the lower body, meaning that if you were doing 1 set per exercise, you were doing 1 set for each exercise, and there were 2 exercises per muscle group for the upper body, and there were 3 exercises for the lower body. So they attained a higher volume. So that equated out to 6 sets. If you were in the 1 set category, that's 6 sets for, or total weekly sets, because it's 1 set per 2 exercises 3 times a week. That leads you to 6 sets for the upper body and then 9 sets for the lower body. Then they had 18 sets and 27 sets respectively for the 3 set group, and then they had 30 sets and 45 sets respectively for the high volume 5 set group. So that's how they set it up. Now, in terms of the diet itself, They used self-report, so they didn't control for calories necessarily, but they did make sure that they quantified calories in terms of just having individuals report their caloric intake. So again, didn't control for calories. So they were told to maintain their nutrition, and they kept track of their diet through MyFitnessPal, which is incredibly common and something that the researchers can then just keep going back to and figure out, on particular days if they had more or less calories, things of that nature. And they were told to maintain their nutrition, but they were also given a protein supplement. All of them were given a protein supplement, the same protein supplement with the same quantity, obviously, just to make sure that they were consuming enough protein to recover from each of these training sessions. Okay, so their measures were actual functional measures. So they wanted to find out, of course, strength. They have to figure out strength. So to do that, they ended up using a 1 rep max. So it's pretty typical if you're going to be increasing strength and you want to actually measure your strength that you've gained over time, because I think they did this for about 8 weeks, an 8-week study. You want to measure that through a 1 rep max method. So that's essentially just lifting the highest possible weight that you can lift with the best possible form. If your form starts to break down, that's not considered a proper 1 rep max. The other thing that they did was they measured endurance. So they wanted to measure strength. They also added endurance in there. And then, of course, they're going to have hypertrophy or muscle growth itself. So endurance, they measured through a 50% 1 rep max. So they did 50% of the measured 1 rep max. And with that, then they were able to determine how many reps those individuals were able to fulfill with good form to failure. So just slap it on 50% weight and then just tell them, go at it, make sure that your form stays perfectly good as it's supposed to be. And then from there, they're able to figure out how many repetitions people are able to accomplish. And then they measured muscle growth, but obviously they can't just slice the muscle off a person like they might in other scenarios like an ex vivo situation. This is called an in vivo situation, meaning that the subject, the participant, the human being has to stay alive. Pretty important. Otherwise, it probably would infringe on some ethical guidelines. So using an in vivo system, they were limited because they couldn't just take out the muscle and weigh it. So what they did was they used a ultrasound machine, which allows you to picture, just kind of like if you are having a kid, they use ultrasound to picture kind of the inside of the body. So they're able to use that to figure out how much growth is actually occurring down to the millimeter. And again, I mentioned that they had 45 subjects, but 11 of them ended up dropping out for various reasons. In terms of where they measured, well, actually, I'll get into that once I get into the results, which actually let's go ahead and jump into that. Well, they did 3 times. They measured the ultrasound 3 times just to make sure that they're getting an accurate reading on everything. Okay, so let's jump into the actual results. For the squat 1 rep max, so this is a measure of strength, they saw no difference. So the 1 set, 3 set, 5 set condition, the low volume, moderate volume, and high volume, they showed no difference in strength gain after 8 weeks. I believe it's 8 weeks for strength in the squat, which is pretty interesting. And we'll be figuring out exactly what that means later on. The bench 1 rep max, so again, they did the same thing, but for the bench press to measure essentially kind of upper body strength, they found, again, no difference. So squat and bench, no difference. Endurance capacity, again, no difference. So here you've got three different measures in strength and endurance, which are not dependent on volume, which is really, really interesting. It could have some serious implications when it comes to training methodology and just how individuals go about their training from here on out, if this paper ends up translating in other papers. And I'll be discussing briefly a few of the other papers that they mention in this one as well, kind of in the paragraph section. Now's where things start getting a little more interesting in terms of like the muscle hypertrophy. In muscle hypertrophy, muscle growth, they measured the bicep, tricep, the mid-thigh, and the lateral thigh. So the mid-thigh is essentially just your leg, right? But at a particular point, midsection of your leg. And then they had the lateral thigh, which is just another point. It's a great way to just make sure that you're getting measures that are consistent across several different places on the same muscle group. So the bicep, they saw that there was a significant difference with 5 sets over 1 set. So the high volume condition saw greater muscle growth with their bicep growth compared to the low volume condition. However, they saw little difference or minute differences between the 3 set or moderate volume to the high volume. So this essentially implies that more volume leads to greater muscle growth. And they actually show that in figure 2 if you're actually looking at the paper itself. I've got that linked, so in like a number of different locations, so you should be able to find it easily enough. They show that in figure 2. So you look at I think 3 in figure 3A. So 2A was looking at the bench press strength. B was looking at squat strength, and C was looking at muscle endurance. And for all 3 of those, even though you're not seeing necessarily the asterisk of significance, those are all non-significant. But for 3A, looking at bicep growth, you can see that there's a stepwise increase. So if you look at the dots, so ignore the lines. The lines are essentially just, again, an indication of the individuals. So from the beginning of the study to the end of the study, did they go up? And for the most part, they did. You might have a few individuals that are going to respond differently than other individuals, but for the most part, you're going to see this average of an increase in muscle size with, of course, training. So they've got 3 different graphs. The one on the left is the 1 set condition, so the low volume condition. The middle one is, of course, the moderate condition. And then the one all the way on the right is the high volume condition. And with figure 3A, you can see that there's a stepwise increase in the overall increase in muscle size. So for the biceps, they do respond to higher volume better than they do to lower volume. Now, B, for the tricep, interestingly, they did not see a difference. And that's, and you might think, okay, well, looking at this graph, okay, you're still seeing this stepwise increase. Well, that's true, but the bars, so if you look at the black dots, the bars that are above it and below it are so wide that that essentially means that there's a great range, or there's a great deviation across the different participants. So it's so wide that it essentially infringes on the previous volume condition. So let's take, for example, our 5 set to our 3 set condition, our high volume to our moderate volume. You can see that the bars are so wide that they kind of impede onto one another, especially the moderate volume condition. So because of that, that essentially masks our ability to determine if there is an actual increase in hypertrophy with volume. So based off the data here, the answer is no. So you don't see an increase in hypertrophy with volume. However, when you look at the quad, or again, the thigh, the mid-thigh and the lateral thigh, you're seeing that there is a difference, again, with 5 sets being supremely superior to 1 set. So the high volume is superior to the low volume condition. But there is a weak difference, or there's a slight difference. There's a slight increase in hypertrophy with the 5 set, again, the high volume compared to the low volume. Or no, not the low volume, excuse me, the moderate volume. So the difference between the 5 set and the 3 set, there's a small difference, but there's a big difference between the 5 set and the 1 set. Again, high volume to low volume. So this is pretty interesting information because really, well, I'll get into how we can actually use this information a little bit later on. But I'd like to jump into the diet. So some of the differences in diet, and they've got a diagram for this as well. So table 2 shows essentially the comparison between the different groups. Again, you've got these 3 groups: low volume, moderate volume, high volume, and you're seeing that the caloric intake was not different between conditions. But you might look at that table and see that there's a massive standard deviation, and that's essentially probably why they can't find a difference between the conditions. Most likely there really isn't a difference between the different groups. Now, in terms of protein, carbohydrates, and fats, again, there isn't a difference between the conditions. So that's all actually really encouraging to see, because if you saw, let's say, for example, in the 5 set group, if you saw a massive increase in calories or you saw a massive increase in protein, I think those would probably be the 2 most important ones, then that could imply that they are seeing better muscle hypertrophy because of their increased caloric intake and not because of the added volume. So in this case, they're essentially saying that that's not the case. Now, some added notes, which are pretty astounding, that they mentioned in the body of the actual paper itself. The 1 set per exercise group, so the low volume condition, worked out for 13 minutes for the entire session. So each training session lasted only 13 minutes on average. And they trained 3 times a week. Okay, 3 times a week, 13 minutes. So 39 minutes in total of workout time. And we're going to get into the conclusions in just a little bit, but that has some incredibly serious implications there. I say this a lot, but it's going to blow my mind. It does blow my mind, the conclusions that we can get from this. So once the 1 set group also was the low volume here, and they do mention another paper, the Ralston paper, which showed a benefit with in strength with higher volume. But interestingly, the low volume of this paper was actually equivalent to the moderate volume of that paper. So the results actually aren't divergent. They're in the same vein of thought. So essentially, that could mean that this paper is kind of on the low end, the lowest end of the volume spectrum, and we're still seeing the benefits that we're seeing. And then in terms of endurance, they said that the endurance improved with higher volume in the Radelli paper, but that Radelli paper looked at new lifters. So there is an effect that's called the learning effect, in which new lifters, and this happens all the time in science in general, but certainly in exercise science, if you've never lifted before, if you haven't lifted in a very long time, there is going to be usually around a 2-week period, sometimes longer, sometimes a little bit less, in which people are going to have to acclimate themselves to the exercises themselves. So while they're seeing rapid improvements, but not necessarily because their musculature is adapting a whole lot, but potentially because their neural system is improving. Or just in general, they're getting in a situation where they feel better about the exercise. They feel more comfortable around the exercise. So in new lifters, they saw an increased volume did have a betterment in endurance. And they used a different type of endurance measure than they did in this study. But in this study, they showed that more volume did not increase endurance. So what are our conclusions? Well, this is where things really get interesting. So the conclusions that we can get from this is that strength can be near maximized at low volume. So they showed one set at 8 to 12 repetitions, and I don't even think I mentioned that earlier. So they're doing 8 to 12 repetitions. They're not even necessarily focusing on a real strength, like powerlifting levels of repetition ranges, but one set per exercise, and that's 2 exercises per muscle group, 3 times a week. So that's a total of, and this is just for upper body, 6 sets in total for upper body and 9 sets. So they increased it by adding one more exercise for the lower body. 9 sets for lower body showed equal strength to individuals who, let me quick find, to individuals who did 30 and 45 sets. So you can either be in the gym for hours and get the exact same benefits as an individual who, as I mentioned before, which blows my mind, is spending 13 minutes in the gym. If you're spending 13 minutes in the gym and you purely just care about strength, you can get all of the benefits that you would if you had spent hours in the gym. So efficiency matters a whole lot. Hey, Richard, welcome to the live stream. So thanks, appreciate it, Marco. So that is really that is going to have some serious implications. This is a brand new paper. It's 2019. So that's really going to have a serious impact on how we go about training from here on out, because, and this is actually based off another paper by Schoenfeld, and I'm sure I'll make a video on this in particular, where he shows that intensity can be really high, and where you can get similar hypertrophy at low repetitions with high intensity, meaning high muscle strength, and that can feed into your hypertrophy. So you can do like 1 to 3 repetitions at high weights, and that will feed into your hypertrophy. So if we can use that principle and apply it here and then apply it to our training, then we could technically become much stronger in a really small amount of time. But then if we want to, we can add hypertrophy on top of that, which I'll get into in just a second, by simply just increasing our volume. So that's going to be a really powerful technique. And I'm sure a lot of people are already doing it, but now we actually have more of a scientific basis for why. So in terms of hypertrophy, so we just talked about strength, low volume is just as effective as high volume in terms of strength, 13 minutes compared to an hour or more in the gym. Hypertrophy is maximized by volume. So doing more repetitions, doing more sets in the gym leads to an increase, and it's a stepwise increase. It continues to increase the more volume that you can do, which actually there's a paper, I think 1 or 2 years ago, something like that, where they looked at 10 sets as their maximal amount of volume that they did in a week. And this paper, their low volume condition is around that 6 to 9 sets. And that paper that looked at 10 sets as the high volume essentially showed, yes, there's a stepwise increase. With more volume, of course, you're going to see increases in musculature. You're going to see increases in hypertrophy. So this is going way beyond that and showing that going up to 20, 30, 40 sets still continues to increase hypertrophy. So you're still seeing that stepwise increase. And of course, eventually it'll curve out, and we haven't exactly reached that limit of how many sets is just, it's going to confer no benefits whatsoever. So anywhere from 10 and up to like 40 sets in a week, not in one training session, in a week, leads to an increase, a stepwise increase in hypertrophy potential. So hypertrophy is based off volume, and I've said that on multiple occasions based off that previous paper, but this is another paper that's going to certainly add credence to it. hypertrophy is going to continue to increase with volume. Strength is not. Now, endurance. Let's quick talk about endurance. Endurance is a bit ambiguous because here they're talking about how the low volume condition, which of course they didn't train for endurance, so keep that in mind. They didn't train for that at all. The low volume condition was just as effective as the high volume condition for endurance. So they saw no added benefit from increasing volume on endurance. Now, of course, that could just be because they didn't focus on endurance. And they mention another paper. I'm not sure which one it was exactly, if it was the Ralston or if it was it was the Rodelli paper, where they did see improvements with endurance, with higher volume. So higher volume led to endurance. And I mentioned the learning effect. That could possibly be one of those factors as to why that happened. So endurance, I don't think we can make a huge conclusion out of that, just because they do mention some papers that are opposed to this one set model, but it could also just be a difference in methodology. So it could be that in trained individuals who have been training and know how to work out, and again, typically you don't not train for endurance to improve your endurance. That doesn't make a whole lot of sense. Typically you'd want to train endurance to improve at endurance. So in that capacity, I think endurance is a bit more ambiguous, and we can't necessarily make a whole lot of conclusions out of that. But the big two takeaways are that in trained or intermediate lifters, I should say, strength can be near maximized at low volume. And I have more to say on that, and I'll leave that for the examined content. But strength can be near maximized at extremely low volume, and hypertrophy is maximized continues to maximize as you increase volume. So you could walk into the gym, do a top set or two, depending on how many exercises you do, a top set, 2-3 sets, something like that of a particular exercise. Let's take squats, for example. You go up and you do, let's say 5 reps, 3 reps, something along those lines. And then from there, you could back off and do no more strength training, where you just focus on hypertrophy, and you would see the benefits in strength as well as the benefits in hypertrophy if you just started jamming out a bunch of reps just to get that stimulation for hypertrophy, which is really, really remarkable. So that's essentially it. That's what I've got for you. And I will definitely be getting more into this. I'm going to, of course, have the examine piece that's going to come out. I'm going to have extracts coming out, and I will most likely have a praxis where we apply some of the principles here to increase our strength in the most efficient way that we can possibly increase the efficiency. Yeah, but anybody who's listening to this on the podcast, or if you are watching this, then I wish you a wonderful day, and I will see you and speak with you in the examine piece and in future content. Have a good one.